Yes, welcome to the chemistry classes, online classes, my dears. So today I am going to discuss about the properties of ammonia. And here you should remember the physical properties of ammonia. Basically, in previous chapters, in previous classes, you may have learned that how the ammonia is made up of with the help of Haber's process in a large scale industries. So basically, ammonia is prepared in a large scale industries with the help of Haber's process. Haber's process is used to prepare the ammonia by using nitrogen and hydrogen gases. Pure nitrogen and hydrogen gas will use to prepare a Haber's process. We use to prepare ammonia in a Haber's process. Now let us go to the what are the physical properties of the ammonia. Physical means by touching. We can sense with our sensory organs, either way by smelling or by touching or by tasting of the compounds. That is what we call physiological nature of the products or compounds, whatever it may be. Okay, the physical properties. What is ammonia? Ammonia basically how it looks like. It looks like a colorless. It is a transparent gas. It looks like a colorless, and it has a very pungent odor. What is the meaning of pungent odor? We can't able to inhale the gases how we are respirating normally. The same we can't able to inhale the gases. This is very bad smell, like a toilet smell. So that is what we call pungent smell. And basically, this ammonia is slightly a alkaline taste. That means why? Because ammonia is highly soluble in water and it turns into a base. So basically, we know that bases gives a bitter taste. If you take a soap water, if you taste a soap water, that gives a bitter taste. So in the same way, the solution of ammonia gives a bitter taste. Is it clear? And one more point you have to remember: it is a non-poisonous. Ammonia is a non-poisonous. That means what? A little inhaling of ammonia that affects the respiratory tract. Respiratory tract. But so continuous inhaling, that means more large amount of ammonia if we inhale, definitely it fatters the it causes the death also. That we can say that. That is what that is what one more property of ammonia. Then what is the third property of ammonia? If you take a density of ammonia. So you have learned that how to test the densities of the gases. So basically there is a relation between the molecular mass and molecular weight, molecular mass and vapor density. So there is a relation between molecular mass of the gas and vapor density. So molecular mass by 2, that is weight by 2, is nothing but vapor density, I would like to call. Okay, so what is the molecular mass of ammonia? NH3 is made up of NH3. NH3 is made up of 1 atom of nitrogen. Mass of nitrogen is 14. 3 atoms of hydrogen. Mass of 3 hydrogens of atom is 3. So total is 17. So mass of the ammonia is 17 divided by 2 gives the density. How much you will get? 8.5. I think so. Okay, 8.5 will be the density. So what is the density of the air? Okay, if you know the density of the air, so naturally that is a calculated value is there. That is 14.5 is the vapor density of the air. Okay, so here we are. If we come to the density of ammonia, density of is nothing but mass by volume, basically the mass. Okay, so density of the ammonia is basically, it is ammonia density is lighter than the air. So ammonia density is NH3 density is lighter than the air. Why it is lighter than the air? Because of its molecular mass divided by 2 is nothing but the value is very less when you compare to the air. So ammonia density is lighter than air. That is a third point you should remember. What is the density of ammonia? That is basically 8.5. What is the density of air means? That is basically 14.5. So that is the reason always ammonia gas will collect it in a downward displacement of air jar. So you have already learned in the preparation of ammonia topic. Next, fourth point you should remember, the solubility of ammonia. So basically this ammonia gas is very violently soluble in water. Okay, compared to the HCl, hydrogen chloride gas, ammonia is more soluble than the hydrogen chloride gas in the water. How many? So what is that next point means? Solubility. What is the solubility? The ability to dissolve a solute in a solvent. That is what we call solubility. Here solute is ammonia, solvent is water. So how this ammonia gets dissolved in a water? How many times it gets dissolved in a water? Basically, as per my knowledge, is ammonia is highly soluble in water. Ammonia is highly soluble in water. Highly soluble in water. How many volumes of ammonia gets dissolved in a water. So basically, you should remember very importantly, 702 volumes of volume of ammonia can easily soluble in easily soluble in 1 volume of water. Ammonia soluble in 1 volume of water. That means generally just imagine 702 liters of ammonia gas. 702 liters of ammonia gas can dissolve in 1 liter of water. So one volume of water at what condition? At given temperature and pressure around 20 degrees centigrade temperature at 1 atmospheric pressure, 1 atm pressure, atmospheric pressure. You should remember. Okay, so that is the point. What you have to remember. Okay, so this is what about the solubility. So you should say that ammonia gas is highly soluble than the hydrogen chloride also. So how many times? 702 volumes of ammonia can soluble in 1 volume of water at 20 degree in temperature at a given pressure of 1 atmosphere. So next, so how to check the solubility? To check the solubility of ammonia, we will use the fountain experiment. We'll use the fountain experiment. You should remember fountain experiment. And what about the next property of ammonia? Sir, can we able to liquefy? What is the meaning of liquefaction? Liquefaction is nothing but conversion of gaseous state into a liquid state by bringing the temperature down. Okay, by bringing the temperature down, by freezing the gases, we can convert them into a liquid. So that is what we call as liquefaction. Liquefaction of ammonia. What is the liquefaction of ammonia? So ammonia can easily liquefy at very low temperature. Yes, we can do the liquefaction of ammonia gas into a liquid ammonia. Liquefaction, we can do it for at very low temperature. We can liquefy the ammonia at below what is the melting point of ammonia? Boiling point means below around minus 33.5 degrees centigrade. Minus 33.5 degrees centigrade. When you bring the temperature of ammonia gas below minus 33.5 degrees centigrade, then because this will be the boiling point of ammonia gas, if the temperature falls below boiling point of that particular gas, that gas converted into a liquid. So around minus 335.5 degrees centigrade temperature, we can easily liquefy a gas into a liquid ammonia. So can we able to convert that into freezing, that liquid? Can we able to convert that liquefied ammonia into a solid? Yes, of course we can convert. That is the reason the freezing point, when we convert means at what temperature we can convert that liquid ammonia into a solid ammonia. Liquid ammonia into a solid means because the freezing point says that conversion of liquid into solid. So at what temperature? At the temperature around minus 77.7 degrees Celsius. Should remember. Okay. So this freezing point itself acts as a melting point, and boiling point itself acts as a liquefaction point. Okay. This is the properties of ammonia. You have to remember. So very simple. Okay. So to demonstrate the solubility of ammonia, we can study with the fountain experiment. That is what blue fountain experiment. Okay. So that is we'll discuss in next class. I hope this information is useful to you all. So if you like my video, you can like it, and you can subscribe my channel also. Thank you very much. Next class we'll talk about the remaining topic. Thank you very much.